event is a partnership with Lawrence Berkeley Lab and the California Energy Commission. We are pleased to have their partnership for the last 5 years. Hope to keep that moving forward. For those of you that don't know about the Silicon Valley Leadership Group, we were founded in 1978 by David Packard of Hewlett-Packard. We cover all sorts of policy issues ranging from energy to tax policy to education. I lead our energy portfolio, which includes data center efficiency, which is why we have the event here today. So we have this great event planned for you all day long. Please do stick around through the end. Our last case study is by Victor Garcia in the back at Brocade. He has a really interesting case study on temperature, so you have to come to that. Logistics. The restrooms are in the hallway as you came in. Our lunch is a box lunch, and we're actually going to have a working lunch. So at lunch, be sure to go grab your box, head into the breakout rooms. We have 3 great sessions planned for you. We know the Giants game is at 5. We'll keep you posted on the score, but I hope that you will stick around. We've got a donation from Gordon Biersch. There's lots of beer. We need you to drink it. So without further ado, I'm going to introduce you to our host executive, Andrew Feldman. He founded C Micro, which was acquired by AMD. So now he's with AMD. Pass it off to Andrew.
Instead, we're just going to say we're honored and excited to have you guys here. My understanding is this is the 5th of the Data Center Energy Efficiency Summits, and I think this is, we hosted the first one as well. So we're pleased to have you guys here with us today and excited about what's happening in our space. I'd like to thank Carl Guardino and the staff, the Silicon Valley Leadership Group, for organizing this and providing you beer and all sorts of snacks and ball game updates. I see ties in the audience, and that has made me rethink the joke I'm about to tell you. An engineer comes home after a hard day's work, and there's a note on the fridge, and it says, honey, this isn't working. I can't take it anymore. I'm leaving. I'm at my mother's. And the engineer is confused. He scratches his head. He opens the fridge door. The light goes on. He reaches in. He touches a beer that's cold. Looks like it's working to me. This is a good backdrop for what I'm going to talk about today. Energy in the energy efficiency in the data center. And it begins with the question: are we focusing on the right thing? And often, as engineers, we focus on being right rather than on the right thing. And so, I'd like to begin with a discussion of where we've made progress in the last 5 or 7 years, and talk about where we haven't made progress in the last 5 or 7 years. I'm not going to bore you with the latest data from Jonathan Coomey about how much power we're consuming in our society. I assume because you're here, you know that. And you also know that, that the Silicon Valley is the engine for growth in our economy. And to the extent that in our data centers here, we are spending money on electricity, we're spending money on space that could otherwise be spent inventing things, creating jobs, it's probably not a good buy. And so you know those things, and I'm going to trust that and not dwell on that. Instead, I'm going to talk about where we've made some progress. And I think we've made tremendous progress over the last 5 years in the actual facility of the data center. Okay. 5 years ago or 6 years ago, the truth is there weren't very many mega data centers. And those that were built were often repurposed. they were often repurposed, and they were punishingly inefficient. And so when you looked at the amount of cooling and loss in energy you had in these buildings, and we call that the power utilization efficiency, it was extraordinary. For every unit of electricity that produced work, we were often paying 1.5 units of electricity to cool. And why was that? I think that was the case because this was new. And building facilities the size of football fields and cooling tens of thousands of servers at a time was something that was new. And in new areas, right, we have the ability to make very rapid progress with modest work. And that was sort of the low-hanging fruit in data center efficiency, was how do we take these buildings and make them more efficient? Right now, the best-in-class buildings for every unit of electricity that goes into compute, 3/100ths is used to cool. That's pretty good progress in 5 or 7 years. It's pretty impressive. We did this a number of ways. We did this by finding areas where we could use outside air to cool. Eastern Washington, Primeville, Oregon, along the Rogue River. We did this by moving some of our facilities, some of the data centers in the industry to very low-cost regions for power, near dams. And we also looked at the building as a system. We looked at every aspect of how we moved hot air, how we cooled servers. And so I think that's one where, as an industry, we can pat ourselves on the back and say we have made tremendous progress in that period of time. There is another area where we've made modest to no progress, or very little progress, and that's the area that I focus every day on, and that's the actual server. The actual server, we've made very little progress on, and that's very disappointing. And it's disappointing because servers are the power consumer in the data center. And when you think about companies like Facebook and Google and this collection of companies, not just in the Valley, but Baidu and Alibaba and China and everywhere, right? They're in the business of giving away compute. And so their business is to give away compute in return for the probability you click on an app. So they have huge and insatiable demands for compute. And as a community, we have done a poor job of improving that. Why is that? Well, unlike super big buildings, right, the server itself isn't 5 years old. It's 30 years old. And so we had made incremental progress along the way, but we were being asked to improve a mature technology, not an immature technology. And the big leaps and bounds you can make with mature technology are more painful. They require more R&D. They require multi-year investments. And that's why we've made less progress on that front than I think we would like. Now, we started as an industry. I'll get to what we're doing at AMD in a minute, but we started as an industry, again, at the low-hanging fruit. We looked at power supplies. How do we make the power supplies more efficient? Right? It was a travesty that power supplies were bringing in power and wasting 18% of it right away. Like that. Do better. Use less. Right? So the industry was able to quickly move forward, and now most of the power supplies waste 7% of the power right away. Still not great. And we have tremendous opportunity to improve on that front. But what I have spent the last 5 years working on is ways to build better servers themselves. And how to take power away from the server. And the result is a set of servers that use a quarter of the power and take a sixth of space transformed the way we built out these facilities. Right? And there was multiple blocks of technology. But an important thing was that it took a long time. It took us 4.5 years. It took us $50+ million of investment to invent this technology. And right now, there is not an appetite in the venture community for that type of investment, for this type of project. And we benefited from two things. We benefited from a grant from the Department of Energy and a peer grant from the state of California. Both of which allowed us to move research forward. That allowed us to move research forward where we might have struggled at that point in time to raise the venture money that we needed. And so those are just, I have no grand observation aside from the fact that that was really useful money. And we put it to good work, and we created jobs, and we created technology that now powers tens of thousands of servers, saving megawatts a month. Let me talk about one or two other items. This is one that bothers me a great deal, and you will hear this frequently in discussions of efficiency in the data center. We will say we need to do better, we need to improve. And someone will say, well, look, we've already improved a lot, and if you buy something on Amazon, it's much more efficient than if you were to drive to the store. Right? And you hear this line of thinking a fair bit. And I like your choice of music. That's nice. You hear this line of reasoning a fair bit, and I encourage you to squash it dead. I encourage you to remember that when we moved from whale oil lamps to kerosene, we were making improvements too. And when we moved from the kerosene lamps to electric, we made improvements there too, even though we were burning particularly filthy coal at that time. And as we moved to other forms of power generation, we've made improvements. And that just because we don't have to drive to the store to get our favorite book doesn't mean that we put the period there and say our work is done. And that the notion of what we have to do in the data center, the amount of work we have still to do in improving the efficiency and the potential is enormous. We've really only been working on this problem 5 or 7 years. Right? It's only recently where the largest of these facilities forced us to take power seriously because they were consuming 60 or 70% of the OpEx of the internet brands. Power and space dominates cost. And so, to the extent that we're a little bit better than driving to the bookstore, we're probably not as good as driving to the library, but we're probably better than driving to the bookstore. It's a terrible thing to retard or stunt our aspirations at that point. That there is no reason why our facilities can't be radically more efficient. And I think you're going to hear throughout the day of different ways we can do that. The way I know best is to build more efficient servers. What I've dedicated time, and there are 100 guys in a building around the corner here who dedicated the better part of the last 5 years, missed your kids' baseball games and dance recitals and 20 other things, is because we believe that a technology like the server, even though it's 30 years old, can be radically improved. And that innovation is not something that is foreclosed to the startup. It's not only the domain of others. That those in this room have every ability to help impact the data center and the drive and the need to improve our efficiency. And just to wrap up, because I'd like to get us off on the right foot, I'd just like you to not be the engineer who is standing at the fridge looking at the wrong problem and worried that unclear on why he has a cold beer and nobody to drink it with, right? And that what we have here is chance, and this is a wonderful forum for us to explore the advantages, not just that AMD has